All right, so what's that warming do? You know, another thing that's often rolled out is, well, you know, it's cooling in Antarctica. Well, there's a lot of debate what's going on in Antarctica because we don't have a lot of thermometers there that go back there. So what I like to do is look at what are the ice sheets doing. They integrate climate over the entire Antarctica, right? And that's the record we're looking at here. And we're also looking at green. What are these numbers? These are measured from space. There's a question before whether we use space-based data, and we do. This is work by colleagues at UC Irvine. And what they do is they measure the mass of the ice sheet, the whole darn ice sheet, because we don't have long, detailed records of ice everywhere around these big ice sheets, nor do we have thermometer records over, but we can, with space instruments, measure the total mass of ice. And in both cases, Greenland, where we can actually have decent measurements of that, this something else, and Antarctica, which we don't have a lot of in-situ measurements, we're seeing the same thing. We're seeing a steady decline in the overall size of these ice sheets. And in this paper, they pointed out that this trend seems to be accelerating, although the record is so short, only going back to the beginning of this century, it's really hard to put a lot of emphasis on the fact that it appears to be accelerating. So the Earth is warming, pretty darn clear, and these ice sheets are shrinking. I don't want to talk about this today, but I wanted to bring things out in the news, and today we published a paper that just appeared, and I thought it'd be fun to bring it in because I've never included this in a talk since it was published. And what this is a record, it's a compilation of how sea level rise could affect the U.S. coastlines. And you'll read about newspapers and things tomorrow, probably. And this is just one of the figures in the paper. And what we looked at in this paper is we first summarized all the science about how fast can sea level go up. And the evidence is now pointing to about 1 meter or 3 feet per century. It's as fast as sea level is likely to go up in the future. So by 2100, the end of the century, 3 feet above now. Some people say more, some people say less, but I'm going to guess the next time we have a consensus among the scientific community in a couple of years, this is the number that will kind of be in the mid-range. And what we did then is we said, okay, let's look at how that sea level will affect the coastline in 1 meter increments using the best elevation data from the U.S. Geological Survey. And the reason we went above 1 meter, that's what we could get by the end of this century, is because climate will keep changing, these ice sheets will keep changing, and so we could get meter after meter of sea level rise going into the future. And in fact, in this paper, we highlight that in this century, we could get the Earth warm enough, even by mid-century, if we don't do anything about greenhouse gas emissions, to lock in the ice sheets to many centuries of melting, simply because we'll warm up the atmosphere enough for the ice sheets to lose all this mass, and then the ice sheets will slowly adjust, because the temperatures aren't going to go down once we stabilize carbon emissions. The temperatures will stay wherever they are when we decide to act and curb greenhouse gas. So this, you can think of as 1 meter by the end of the century, and then these other numbers is what we're locking future generations into. Right? That's a map, and you can see, places around the world, around the United States, that get hit really the hardest. Another way to look at it in this paper, we actually provide maps of individual cities, many of them, is we looked at all the municipalities of 50,000 or greater people on the coast of the United States. And there are about 180 of them. And then we did a histogram showing the percent of the municipal area that would be flooded for these different increments of sea level rise. And you can see that in some cases, like New Orleans, 1 meter of sea level rise takes out about 90% of the municipal area, floods it. And of course, you could build dikes, you could move buildings up 3 feet. There are a lot of things you could do. It might be a little costly, but you could do these things. Other parts of the country, such as Los Angeles or Houston, Texas, heck, you can rise sea level 6 meters, or about 20 feet, and you would only flood a teeny fraction of the municipal area. But there are a whole host of cities in the United States, and you can pick your favorite one, that you're going to lose 10, 20, 30, 40% of the area of those cities. And over all of the 180 municipalities greater than 50,000 people. The average is about 10% by the end of this century. And you know, somewhere between a half and a meter every century thereafter will be lost as sea level goes up. And of course, there are lots of things we can do about this, including stopping the cause. But we're not here to talk about what to do. Okay, so what's behind the climate scientists' assertion, the one that we put in the Nobel Prize-winning IPCC report, that the evidence for global warming is unequivocal? Why do scientists who study climate feel confident saying it's unequivocal? There's very little doubt. Here's the reason. There are many reasons, right? Here's the reason I think that's most compelling to me as a scientist, and it appears to be the most compelling to most people I talk to. It isn't any one thing. It's the fact that the Earth is doing a whole bunch of things. It's changing in many different ways that are consistent with global warming, with human-driven global warming. So what's happening? The most obvious thing is that the Earth's surface around the globe is warming, okay? And if you go back to the beginning of the industrial era, the whole Earth literally has warmed just about everything, all right? And that's why they call it global warming. It's warming around the whole globe. Not in every given year, but on average over a century. Okay? We're seeing, these are all statistically significant, by the way. We're seeing increases in extreme high temperatures. We're seeing double now the warm temperature records being broken in a given year than the cold temperature records. We see heat waves. Look at Russia this last year. Look at Europe back in 2003, the one that killed literally hundreds of people. These heat waves are becoming more common. I just wonder what would happen to us in Arizona or to our forests in the West if we got a heat wave like one of the ones that occurred in Europe and Asia in the last 10 years. We'd see some real impacts. Okay, it isn't just the lower atmosphere warming up. We're seeing warming all the way up in the lower atmosphere now. It's consistent from top to bottom. We're seeing the global sea surface warm up. So those people who like to say, oh, it's just cities like Phoenix are biasing the temperature record. No, scientists aren't that naive. We have lots of temperature records far away from cities, indeed way out in the middle of the ocean. You see the same warming. And the thing that's interesting is the warming now is seen over 1.5 kilometers, nearly a mile in the ocean. All right, so the warming isn't just at the surface and all through the atmosphere. It's working its way down into the global ocean. And as it does that, it heats up the ocean, and just like a hot air balloon expands as it gets bigger, we're seeing an increase in sea level, okay, because of that increase in heat in the ocean. And that global sea level that you can calculate how much the ocean should expand matches how much it is expanding. It's measured by tide gauges and satellites, right? As the atmosphere heats up, it can hold more water vapor. It should, and it is. All these things are predicted to occur, and they all are occurring now. As you get more water vapor into the atmosphere, you get more intense rainfall. So when the rain falls, on average, it's coming down faster and harder. We again see that around the globe where we have the precipitation records. Extratropical precipitation included. Ironically, or paradoxically, I guess, as you increase the moisture holding capacity of the atmosphere, when it rains harder, and when it doesn't rain for longer periods of time. So we're seeing a statistically significant increase in drought around the world. There's a lot of debate about this. Climate scientists agree that we should be seeing more intense hurricanes. There's a debate on if this is happening globally. The scientists seem to agree it's happening in the Atlantic at least, more Katrinas. We're also seeing decreases in things. It's consistent with this global warming. We're seeing decrease in snow extent. I'll talk about that, as well as these other things that are in orange in a minute. We're seeing unprecedented changes in the Arctic sea ice. If someone wants to ask a question later, this is what's causing this weird weather, we think, down here. And we have record low sea ice extent right now. This winter has been the lowest ever recorded. Glaciers are receding around the world, and all but the places where there's an increase in precipitation that overwhelm the world. And we're seeing a decrease in cold temperatures, which is good for people who live in Canada.